Okay, this is problem number 53. It's a multiple choice question, but we really still need to work this out. And the question reads, two positive numbers have a sum of 60. What is the maximum product of one number times the square of the second number? And like any of these other problems, we come right to the part they want maximized or minimized. And so we're reading right here, what is the maximum product of one number times the square of the second number? So you want the maximum product, one number times the square of the second number. So let's get a function for product. And the product is one number, x, times the square of the second number. We want to maximize that. And again, we notice the two variables. This is certainly our primary equation. And now we get a secondary equation because we know the two numbers have a sum of 60. So we know x plus y equals 60. Solve that for x, solve that for y. If you look down below, we have x just to the first power. So that might be an easier thing to substitute for to avoid foiling something out. So x equals 60 minus y. So I come back down here to my product, and my product is, I'll take out the x, I'll put in 60 minus y, times y squared. I'll distribute that, and it looks like 60 y squared minus y cubed. Okay, how do we maximize or minimize things? We take the derivative. We're looking for critical points. There are no real endpoints here. There's certainly positive numbers, so we know our domain is x and y is greater than 0. But there's really, well, I guess, and there's a max too because the sum is 60. So the biggest would really be 60. So we know both our x and our y are somewhere between 0 and 60. So not really strict endpoints in this problem, but certainly a limit to it. Okay, now we take the derivative, and we take the derivative. It looks like 120y minus 3y squared. We'll set that equal to 0, and it's a quadratic, so it's kind of nice in a certain sense, I guess. We're going to get two solutions. Let's factor out the 3y. Looks like 40 minus y. And I'm seeing a couple solutions. One is when y equals 0. Don't think that's going to be the max because when you put that in the product, you're going to get 0. And the second is when y equals 40. And again, we just kind of note up here in the problem, y was the value that was getting squared. And since the sum was 60, it kind of makes sense that you dedicate more of your resources to the y than the x because that was the one getting squared. All right, is that truly a relative max? We had a min, or I'm sorry, we have two critical points. Don't know if they're maxes or mins. And technically, let's see, 0 is 0 a positive number? 0. No, 0 is not a positive number. So technically, that's not really a critical point either. Let's do the second derivative test to see what 40 is in terms of a critical point. Is that a max or a min? And I'll take my second derivative, 120y. That derivative gives me 120 minus 6y. When I sub in the 40, my second derivative at 40 is 120 minus 6 times 40. 6 times 40 is 240. Subtract that, and I get a negative. So my second derivative is negative. By the second derivative test, y equals 40 is a local max. And on my domain, greater than 0 and less than 60, that's my only critical point, and so that is my max. Now, let's answer the question. The question as we read it is, what is the maximum product? All I found so far is y. Can I get x? Absolutely, because I know x plus y is 60, and since x plus y equals 60 and y is 40, you're probably doing this in your head, but I end up with x equals 20. All right, let's find our product. Let's get a little more space here. So what is our product? Our product is one number and the second number is squared. So our product is 20 times 40 squared. 40 squared is 1600. Take that times 20. Looks like we have a 32 with 3 zeros. So our final answer is 32,000. We can check with the text and see what choice that is. Hopefully that's one of the choices. And I got to double check that. This is problem 53. And that looks like choice D. So our final answer is 32,000, choice D. That completes the problem.